So for this problem, initially I was thinking using a Skype like a set, to find the pair. But the problem I have is like it's gonna be maintain the unique pair, right? Because if in this case I can put 3 in a set, and now I put 1, I see 1, I know 3 and 1 should be a pair, right? But then I cannot remove 3 or 1 in the set. I have to keep it in there, and I keep moving and to find another number. Then it's gonna be difficult for me to maintain the unique pair. I can use like a hash map to type, another map or another set to say, okay, if this pair is already selected, but yeah, I think I could.
So while putting, with your approach, if you make sure that you will always put the smallest element first, because you have only 2 elements, what you want to store in a set, right? For each group of 2 elements you are going to put, right? So in the beginning, you will put 1, 3, and then when you see 3, 1, you will see, hey, like 3 is bigger than 1, so let me swap it because I want to maintain the order that smallest element should be first. So when you will try to go and put that, it will not be added to the set because it already contains that. Will that solve your problem?
So you say you keep the smaller number first in a pair?
Yeah, you have just 2 numbers, so
okay.
It's not tough. It's a temp variable, you can do that.
Yeah, hi, yes, this side. I tried this question using sets itself. We don't necessarily need to put the smaller number first. What I did was like my approach. For example, I firstly put all the elements into the stack. Oh, sorry, in the set, and then it's like if the stack, the set now has 3, 1, 4, and 5. So I started iterating over each element. And first of all, I am on the number 3. So what I did was I figured out 3 plus 2, in this case, like 3 plus k and 3 minus k, which could be the possibles, which could have all the possible pairs of, 3. So, and I counted and I put a counter, which counted if it's helping me out. After that, when I was over 3, then I removed 3, and then I iterated over the next element to check out if, I have more elements regarding that.
Yeah, seems like, yes, you have done this question, and it seems to be a nice approach for me. And it would be, what's the complexity of this particular, like it's order of n, I suppose?
Yeah, it's order of n. It's order of n for, to go through all the elements in the set, but to insert all the elements into the set, if, yeah, that's order of 1, so it's order of n.
Yeah.
But there was one problem.
And complexity of inserting in set is order of 1 or order of n? I'm not sure.
That's order of 1.
Okay. Yeah, that's order of 1.
But I encountered one problem into it. When the k is equal to 0, then sets wasn't helping me out.
Yeah, that seems to be a problem.
So I made a case for it, and I used maps for the specific case when k is equal to 0.
Got it.
For k equal to 0, I just checked whether it's equal to, if the count is equal to 1, then we have to continue the loop. Otherwise, if it's greater than 1, then we can increase our count.
Yeah, it's the problem is only with the case when k is equal to 0, because we have to check all the elements which are repeating more than 1.
Yeah,
So
so
for
there will
that,
be
I
just one
use hash
special case
map.
for k equals to 0.
So yeah, seems like we have an approach. Can you share your screen if you want to share the code or something?
Yeah, just a minute. Let me just set it up. I'll share the code.
I can share mine. I have.
Okay, no problem. I'll just stop sharing.
Okay. So, is my screen visible?
Yeah, yeah.
Yeah. Okay. So, so the first case is like if the k is less than 0, then we have to return 0 because we can't have absolute value as -1. So, and I used an unordered map and one set as well. It contains a pair of two integers. So in the first for loop, I just added the integer arrays, and then in the second loop, I just looked for nums minus k and nums plus k. So if we have if I got that value, then I just inserted into uh, the I inserted into the set, and I just made one special case for k equals to 0 because if the k is 0, then when we subtract or add it with the integer, then we will get the same integer back. So for that, our like count should be greater than 1. So this was the main situation. I was stuck for a minute.
So you have taken a set. Why didn't you use count for this?
Because like I need different like unique different pairs. So for that I used set because it can help me to like make the question easier.
Okay.
I can show you my approach. That's quite similar, but I guess I've used a bit less space.
Okay, wait.
My internet is troubling me a bit. Let me just fix it in a minute.
Puneet is saying he used two approaches, software and
I have also used two pointer approach with off one space.
I think.
I can share my screen if you guys want to. This is Yash.
Yeah, sure.
Code. Yeah. Where to- Yeah. Here you go. Is it visible?
Yes.
Yeah. So I have made two cases. Specifically, what I have done is I've figured this case out for k is equal to 0. And in case the k is 0, I solved this using an ordered map here. Okay. And if it is, if the k is not equal to 0, so for that case, let me tell you, I first used an unordered set and inserted all the elements into it. So after that, what I had done is when, it's like I was on the first element here. When IT was set to s dot begin. So this iterator is pointing to the first element. In the first example, this is 3. Okay. So here I am checking it with 3 plus k. That is if the set has an element 3 plus 2, that is 5. And if it contains that, so it will increase my count with 1. And I'm also checking it for 3 if it has 3 minus 2, that is 1. In that case also my counter will increase to with 1. Hello.
Yeah, we can.
Yeah, after that I'm just I've taken a temporary iterator, so just I can remove the 3 from the set so that it doesn't create ambiguity when I'll be on 1 or 5 later words.
Mm-hmm.
In this way I have solved it using the, and the other case when I had when the k was 0, so for that case I used a map, and in the map after inserting all the elements I just checked if there is any element whose frequency is greater than 1. In that case I increased my counter by 1 and I returned that simply.
So you are removing which key? Like you are removing s dot erase something.
Pardon?
You are
Okay, yeah.
erasing.
Here s dot erase it2.
What is
That's basic. Yeah, that's basically like if I first I put all the elements like 3, 1, 4, and 5. My set has currently these 4 elements. Okay, so at first I was on element third. When I completed the check on element third for all the possible matches for the k, after that I erased this third from the set, so that when I'll be supposedly like now I checked it for 3 and I got to count 2 because 3 matches with 1 and 3 matches with 5 to give k is equal to 2. After that I erased 3 and then now I have 1, so I'll be checking 1 for 1 plus 2, that is 3, and 1 minus 2, that is minus 1.
So quick question, right? You had 3145. What if we just look in future? So 3 only looks for 5, and when 1 comes, 1 only looks for 3. It doesn't look for minus 1. 3 doesn't look for 1 because it is smaller than that. Will that work?
Pardon?
So you had.
There's some noise coming out.
Yeah, someone is like
Yeah, someone need to mute.
Yeah, there's some noise.
I think. Shall I mute the person?
Yeah.
Yeah. Go ahead and mute.
okay, looks better actually.
Mm-hmm.
So what I'm saying that at every number you are looking into your like mm, neighbor, which could be like 3 minus k and 3 plus k, for example.
Yeah.
Can you just look at 3 plus k? When you reach at 1, you just look for 1 plus k. When you reach at 2, look for 4 plus k, and for 5 you just look for 5 plus k. Don't look at 3 minus k, like number which is shorter than you. Wouldn't that work?
But
Or
if
you go,
Yeah, that's a nice approach. In that case, I think I'll not need to erase the element.
But that would require the set to be sorted, right? Because you look at a smaller number, you follow in particular order. In this case, the sort is, the unordered set. So we cannot do it.
so in the first example which is given, it's not sorted. Can we just still make it work? I'm just asking the question. That's right. Like 31415, it's not sorted. But when you reach that 3, you paired it with 35, which is one pair, right? Then when you reach that 1, you could found that, hey, 1 plus 2 is 3 and it is in the map. I can make a pair, and then you are done. And then 4, it doesn't see 6, so no pair. and again we have 1. So 1 and 3 is again there, but you have already added it to your set somewhere, I believe. It depends on implementation. I'm not thinking about implementation. And 5 is looking for 7, and there is nothing like that. So you could figure out that there are two such, sets which solve this problem, I guess.
Yeah.
Seems
I'm
like
sorry, Roger, can you explain a bit more? Like, I think I heard you, but still trying to get my head around it. You said if it is smaller than the K, then don't use it or ignore it, or what was that?
Should I help you out if you
Yeah,
want
yeah.
to?
Please go ahead, guys, because I'm commuting,
Uh,
so if you will be better explaining it.
I think what Roger is saying is, like I could use just one case and then I need not erase the element again. What I was doing is I was checking for all the possible cases for the element I was iterating over. For example, like when you are on 3, what his approach says is for the first time when I am on 3, I'll be checking only for the element which comes after it, like 3 plus k. So
Okay.
if I check it for 3 plus k, so it check for 5 only. So it will increase the counter to 1.
Mm-hmm.
Okay. In the next pass, when the iterator would be over 1 and we have not removed 3 from the set,
Mm-hmm.
so then 1 will check for only one case if 3 is available to it. Okay. In the,
Mm-hmm.
then the counter would be increased to 2 because it will find 3 in the set. Afterwards, it will go to 4 and check for 6. Afterwards, it will go to 5 and check for 7. And then our iteration over the set will end, and ultimately we'll get our result. Was that the same thing, Roger?
Yes, yes. Basically, the idea is exactly what I was saying.
Yeah.
Yeah, thank you. I think that explains. Basically,
thank you,
you don't.
Yash. So I think we have another approach. Smita was saying, Smita, do you want to uh, explain your?
Yeah,
If anybody,
1 second.
Yes.
if anyone wants to share the screen, I could stop sharing.
Just give me 1 minute. I'm just trying to.
Actually, in the meantime, I want to say that we have two approaches for it. Like iterative one is sorting with pointer approach. I want to mention I got this question in one of the tests, and we need to make sure what's the k from here. Like, is it the k is range between 0 to like n, or it's starting from 1 to n? So if it is starting from 1 to n, then this question can be solved using a two-pointer approach. But if it is from 0, then you need to handle that particular case of 0. So that was one thing I just got I got when I used when I did that in the test.
Could you please elaborate about the two-pointer approach?
So I think Smita is want to explain that problem.
Yeah, please go ahead.
Yeah.
So first, I plotted my array, and
So do
then
you want to share your screen? Smita, do you want to share your screen or
yes,
any?
I can share my screen.
Yeah, okay, I'll stop sharing.
Can you guys see my screen?
Yeah.
Okay. So what I did was I had to sort my array and then use 2 pointers. I started with the 0th element and the first element, which is my start and the end over here. Okay, and result is where I'm counting the elements. And what I do is I check that if ignore this condition for now. If the numbers start, I mean the 0th element and plus k, if it is greater than the array of the end element, then I will increment end. If it is less, then I'll increment the start pointer. And if it is equal, then I basically increment the result, the resultant counter. And in order to continue the loop, I am incrementing the start pointer again.
And what is this condition while start is less than length and?
This is for my loop to exit. Does that make sense?
Can you walk through with an example with this?
Yes, sure. So let's take this.
That's an interesting approach.
I had to take some corner cases separately though for this one. This is the sorted array. Okay. So your start is at 0 and end is at 1. So if start is equal to end, which is not the case, if nums of start plus k, which is 1, and your k is 2,
which is 3.
3. So 3, is it greater than nums of end? Yes. In that case, we will move the end.
I think it's, it's yes.
Right?
Yeah.
Because the difference, you want the difference to be. So then you continue with the loop.
Okay.
Okay. And then 1 plus 3, 1 plus 3, 1 plus 2 is it equal to 3. This is now end and this is start now. So 1 plus 2 is equal to 3, which is the case. Then in that case, you will do, you increment your counter and you also increment your start pointer for the loop to continue. Otherwise, you'll be stuck. And this condition is for the duplicates. When you have all the duplicates, that's when this condition comes into picture.
Okay, makes sense. Yeah, I think this approach would be is interesting, but its complexity of it's like as you said, it's n log n.
Yes. I had to take all those corner cases too separately. So it was more of a spaghetti coding. That is when I took the hash map approach and I solved it through that, and that worked.
Yeah. Okay, makes sense. I think we should move on for the next question then. Anybody has doubt of anybody has other approach for this particular question? Sorry. Shall we move ahead, guys?
Yeah.
I can start, Karen.
Okay. Yeah.
Can you see my screen?
Yes.
Okay, so we have another question which is in a medium bucket, and it's question. This is like complex number multiplication. So the question is, if we have given the two strings, which is two complex numbers, I think everybody knows about the complex numbers. I'm assuming. What's the complex number is? Yeah, so you need to return a string which representing their multiplication, like we need to do the multiplication of these two, and it should be like where we know that I square is equal to -1, which is iota square is equal to -1, we know. From here, as you can see with the example, when we are multiplying 2, then after multiplication, we get this equation, this equation. And after solving this, we get 2i. So you need to convert it to the form of 0 plus 2i. Like if you don't have any number in the before iota, you need to put 0. And similarly with this example, which is, I think, a minus b square, we need to do it like a square minus b square approach. Then this is the equation we form, and here I square is -1, so this forms -2y, and you need to convert it into plus -2y. You need to make it you need to see the sign as well for that, and we need to return the string. And they have given the range. It is between -100 to 100, A and B. So anybody has tried this question?
Yeah, I didn't code the question, but I framed the logic. I guess it's pretty straightforward in this. The task at hand is to convert the string to the numbers and then back after, calculating the numbers, then converting the numbers back to the string, the integers.
Yeah, so do you want to share your approach? Approach would be fine. I think now we need to see the approach only.
Yeah, okay. Just give me a minute. 537. Let me just open the problem. I'll share my screen and I'll show it to you.
Shall I stop sharing my screen then?
Yeah, then just a minute.
Yeah, it seems like, yeah, Puneet is also, yeah, it seems like a simple mathematical approach to do.
Yeah, I could share my screen.
Sure.
Yeah. Yeah, actually I didn't code it, but I could show it here only how I thought it could go. If it's like I have a complex number like a plus b iota, it's a plus ib, and the other one to be multiplied is c plus id. Okay, so in that case, if I'll be multiplying, it's something like ac minus bd plus I, and it's sorry, and it will be
BC.
Yeah, BC plus AD.
Yes.
Okay, so basically the task at hand is to convert at first this A. We need to figure out the A, the B, the C, and the D, and then convert it into the integer from string in a specific languages. And
Yeah.
after that, we could calculate this, say x1, say x is equal to AC minus BD. We need to calculate this, and then y is equal to BC plus AD. We need to calculate both of these, and after calculating this, we need to convert both x and y into strings, and then we could put it somehow like x plus. We need a plus. Plus, and then I could put y, and afterwards I need to add what I need to add to the string is I think this is the only thing, that's the approach we need to follow.
I just have a quick question, like how you are handling the negative cases over here, like if there is a minus.
I think if there is a minus in y, you say, so when we'll be converting it into a string like to underscore string, there's the function in C++. So that will convert us if I have -1 as int x is -1. So it will return me with a string, say x is as -1 only. So we need not handle specifically what I think. I've not coded it, but I think that's not going to create a problem, because here the what multiplication and addition we are doing, that's in totally integral form. So we'll get negative answers or the positive answers depending on the question, and after that we could just add up to the string.
Okay. Seems like a good approach, and can try. And if anybody has questions or anybody have other approach, please
Yeah, please share.
share your. Anyone?
Should I stop sharing my screen then?
Yeah, I don't think anybody have any problem in that.
Yeah. So, okay, yeah, and stopping sharing my screen.
Did anybody try to code it? I don't think so. So Puneet, do you want to send the code or something like I can?
Is this related to complex numbers?
Yes. Yeah, Nikhil, yes, it's a complex numbers.
Well, but the math which the guy was actually putting, like, yeah, I think it might be work probably in my case.
Yeah.
If he gets, like, yeah.
Yes, yes, and Puneet also shared the code if you guys want to see that. That's in the chat.
Yeah. Can you just share that particular screen so that we can even answer that?
Yeah, it's not quite visible in the chat. If anyone can it's not quite clear in the chat.
I'll try to open in a notepad. So Puneet is saying he'll share on Slack. You guys can see that code in a Slack from Slack as well. So anybody have any other question about this? We should move on for other questions. Seems like it's a direct mathematical approach, as Yash has explained. It's a pretty good approach, and even I think that would make very easy to solve that question. So okay, moving on with the next question, and it's from the hard bucket. I'll share my screen. I think this is the one.
Yeah.
Yeah. So this question seems like even I haven't tried this question. I just saw this. It's written like find the closest palindrome. Given an integer n, find the closest integer not included itself, which is a palindrome. The closest is defined as absolute minimum between two integers. I need to mute someone. So it seems like if input is 1, 2, 3, and the output should be 1, 2, 1. That's the closest palindrome as closest is defined as the absolute difference minimized between two integers. So yeah, so I think what it says, like we have given 1, 2, 3, and it's let's it be a string, and we need to find a palindrome which is closest to that number. So closest means it's difference between this and so 1 to 1 is a palindrome, and its difference from 1 to 3 to 1 to 1 is just 2. So which means like it's a closest palindrome with 1 to 3. And it's given that this length would not exceed by 18. And if there is any tie, then return the smaller one as an answer. Like if we have something which is 1 to 1 as well as some other number, then whatever, and the difference of both those numbers from the target is same, then we need to return the smallest one of that. Anybody has any approach for this? Anyone tried?
I tried this question.
Yes, yes.
I didn't code it, but I had an approach, a
Yeah,
bit
you
of
can
the.
share, like, we don't have any approach yet. It would be very helpful if you can share your approach.
Yeah. Like I could make it clear if I share my screen.
Yeah, yeah,
Probably.
sure.
Yeah. Just. That's question number 5. Yeah, see, here I saw a lot. I tried here a lot of examples, and what I found was, there are, if there are a number, like any number, take it like 1, 2, 3, 4, 5. So what we need to do is we need to convert it into a palindrome, the nearest one. In most of the cases, what I saw was the palindrome would be like we need to find the middle element. In this case, like this is odd, so we need to find the middle element, and we need to replicate the left half with the right half, because that will give the lowest absolute difference. That will give the minimized absolute difference. So in this case, I guess it will be 1, 2, 3, 2, 1. And in most of the cases, consider an arbitrary case like, for some 6 digits. So here as well, I think the palindrome number that we want is in this case we have 6 digits. So if we replicate the first half, the first 3 digits with the last 3 digits, so we'll probably get our palindrome number with the minimized absolute difference.
But I also thought the same, but I don't think that's a foolproof case because a number
That's
might
not
still
applicable.
start with, like, let's say in case of 1, 2, 3,
Uh,
4, 5, it can.
and yeah, one more question I had, like if like the palindrome number should be greater than the input number, or it should be lesser than the input number.
It doesn't matter as long as
It's,
the difference
yeah.
between the palindrome number and the given number is minimum.
So
Oh, okay, cool.
If you have two cases, one is larger than the palindrome number and one is smaller. So we have to pick the smaller one in that case.
So, so why you did like 836,638? But it's not that smaller from. It's not the smallest number. Yeah.
Yeah, it's not the smallest number, but like when we have when we want the absolute difference minimized, in that case, if we'll be taking the, ones place, tens place, hundreds place, starting from this, the rightmost place, if we'll be changing the number there, then we'll get the minimized difference only, minimized absolute difference only between the numbers.
I think
What
Puneet
if
is
the
saying
integer
you.
value is like 10,000 and all? Like if 10,000.
Yeah, this case creates a bit of problem. Like if I have given 10,000, so there are two possible cases. One is 9999, and the other one is 10,001. So here we need to choose this number, but going by my approach, you will replicate and get this number.
Yeah, that would make. And similarly, for if you have any number like 3,000 or something like
Yeah,
that.
any number of such sort. And there's a problem with one more case as well. If I have been already given with a palindrome number, like if I have been given this, so I can't return the same number. I need to go to some other palindrome number, and then I'll, like if you could see in this case as well, the test case that I have tried just for the sake. So it is a palindrome number itself, but I can't return but I can't return the same number. I need to find some other palindrome number which is nearest to it. So, but what I think here, I'm not pretty much sure, but in most of the cases, what I think is we are taking the middle number and then either adding or subtracting one to the middle number. In case we have even number of digits, So we are adding or subtracting both the middle digits by 1, and similarly, I don't know specifically, but it's quite like
11 is also one special case. If you have given 11, then the closest palindrome is 9 to it.
Yeah.
But 11 is itself a palindrome.
Yeah. So based on
we
this
can't
caution.
return 11.
Yeah, but you have to exclude the whatever number is
given. Yeah.
And what I think when we have palindrome, like if we have this, so what we can do is, let's suppose we take just one half. Let's suppose we take 10 only for the consideration, and now we subtract 1 from this number. Okay, so we get 9, and then we replicate it to the other half as well. We get 99. I might not be clear right now to you guys, but if I take one more example, like I take 1 2 3 3 2 1. Okay, if this is the number, I have got palindrome number as the input. Am I audible to you guys?
Yeah.
Yes, have you coded it?
No, I didn't. I just checked all the test cases on how I could do it, and this is the only thing that I got.
I think the test case is the key part here, because I'm sure there might be.
So you also, whatever the test cases you run, is it your approach is working in all the cases, or there is some other?
Yeah. Okay. So like if I have been given with this palindrome number, so I just bisect one of its half. I take 123 for consideration right now, and then I could add 1 or subtract 1. Like I'll have 1 2 4 and 1 2 2. Okay, and then I'll replicate the same. I'll take the mirror image and I'll create 2 palindrome numbers using this. It's like 1 2 4 2 1, and 1 2 4 4 2 1, and 1 2 2 2 2 1. So these will be the 2 closest palindrome numbers.
Candidates.
Sorry.
Yeah, I mean to say, we basically need to check the difference of these.
Yeah, and then we need to check the difference, and whichever is the smallest. We could check it once at 1 2 3 3 2 1. This helps.
1 2 3 9 7. What is there on the chat?
So Puneet has given the question about 1 2 3 9 7. So I think its answer should be 1 2 3 2 1.
Yeah, that's pretty straightforward. It's 1 2 3 2 1.
Yeah.
So you see here, I've got the expected result is 1 2 2 2 2 1. It might be because the difference between 1 2 2 2 2 1 and this number is smaller than this and this.
Yes, can you explain the concept again? What you were explaining right now regarding 124 and 122?
Okay, yeah. So you see, we take any number as the test case, any palindrome number. If if I take like 963 369, I have this as the input. Okay.
Okay.
So first of all, I take into consideration the first half of the number. So the first half here is 963 only.
Okay.
So
you move it.
Yeah. What I can do here is I can either add 1 to it or subtract 1 from it. So I could do it like 964 or 962. Okay.
Okay.
And then what we just need to do is we need to create a mirror image of the same. It's like 9 6 4 4 6 9. or 962,269, and we need to choose one among those, among these, which one is smaller. But I think in most of the cases, the one that is smaller would have less difference. Going
And
like,
that is 962, right? That will be the less difference.
yeah, I think
So,
so. That just
so
strike
in
it.
that case, then it will be taking 962,269.
Yeah, in most of the, and I think in all the cases, maybe we need to take the smaller number only. We need to just subtract it by one. We don't even
So
need.
how will like this is, and I think a human side approach. How do you tell the computer like, yeah, 96, like 960, or if you mirror it with 369, it becomes 360. I'm asking in that case, like 962, it's okay. When you subtract with 963, it becomes 962. But after that, the 269 process, I'm asking.
That's actually, we would have been given a string here. So that's quite an easy task to do. Hello.
Well, okay.
We have got a string here, so I don't think that will be a problem.
So that, yeah, you just have to take it reverse from half and convert.
Yeah, reverse and join.
Yes, I have one doubt. Can you take an example of a even number, basically the even count, not the odd,
The odd count, I guess.
Even like 300,
which doesn't have the middle element?
3000.
This?
Yeah, let's take.
Yeah, let's do with that.
Okay. So in this case, see, the earlier cases were what I told here. This was regarding when I have the palindrome number given. I need to check it first if it's a palindrome or not.
Yeah.
If that is a palindrome number, then this approach will follow the one which I told here.
Right.
And in this case, what I think is like we'll have 3003. There will be two possibilities. One is going by this approach that I told, it will work in most of the questions. One of those number would be 3003. We'll take half and replicate it. Hello.
Yeah, we are there.
Okay, and the other number, I couldn't really think of it.
So you were saying something like subtraction and then coming up with like 30 is subtracting with like 29, like 29, and then
Yeah,
yeah,
like,
yeah,
29. Yeah. Even I was about to say that.
I think that thing is more, that will work a bit better when I have something like this, 1001, because we'll have two quite close numbers. One is 99, it's 999 here, and 1001. So either we need to explicitly tell the computer to handle such cases, or
if the difference is equal, then we need to take the smaller one. Like
yeah.
that.
So in this case, we have the absolute difference, one for 999 as well and for 1001 as well. So in this case, we need to take the smaller one, but I'm not sure. How do we need to tell the the environments explicitly for this case to handle such cases where we'll encounter 1,000, 10,000 or so?
Will it work for odd numbers or digits?
For the palindrome number with odd digits?
No, I guess he's asking normal number.
Yeah, it will work. We have taken two examples here. This has 5 digits, and it gives me, after replicating the first half, it gives me 1, 2, 3, 2, 1. We just need to
change for 9,999.
Just a minute.
Actually, it's given that you'll not exceed 18 digits. Yeah.
Are you talking about this?
Yeah, Puneet asked for this.
Yeah. In this case, what I told here, I think this will help. What I told over, we could bisect it. We could divide it, so we'll get 99. And then what we could do is we could add one and subtract one. So adding one will give me 100 and subtracting one will give me 98. And then I could take a mirror image of these. So it will give me this, and 98 would give me 9889. And so I think
I
this
think
will help me in this case as well.
Yeah, 9889 is more closer. Yeah, this is work. Actually, Puneet is saying the answer of this is 100, like 10001. Yeah, answer is
Yeah,
10001.
basically 10,001.
This is more closer.
Yeah, this is more closer. Correct. So how this would be solved? Like remove 10 from this, the answer should be like that.
10, yeah, from that answer.
Okay. Could we just do it like, let's try it first for 3 nines. Okay, for 999.
Okay.
We have not taken any number with odd number of digits yet. So for this case, what we need to specifically do is, if we fetch the middle element, it's 9 only. Okay, and then we add, if we add one, no, it's going to be a bit problem here. I'm sorry, but I couldn't specifically handle this case.
Yeah, there is one more, like 22. If input is 22.
The input is 22.
Yeah.
So we'll have 11 and 33. In this case, we could.
You're adding
the half.
Take half minus
and
1.
decreasing.
And
Okay. Okay. Yeah. Then it will work. Yeah. Got it. Yeah. So only 1000 case is something which we need to take care separately.
Yeah, the 1000 ones and the 9999.
Yeah. I mean, whenever it's multiple of 10.
And also, if here, like I took 963369. If I take 96369, then I think it's quite straightforward. What we could do is we could just change this 3 to 2 or 4.
Yeah. But I think it's very hard to code. Like you don't.
It seems we need to write something special for these 100, even if given number is 100, 1000, 10,000, or after our approach, it reaches to those things. Right? Then only we are.
But from thinking perspective, it's very nice. Like, I mean, as a human, we can devise this, like it's working. But I'm sure there are some cases which we are not aware with.
Yeah, but I think these two will be those specific cases. I've not checked the solution tab yet. Should we check the solution once? If we get some.
When everybody says yes, we can check.
Yeah.
Or someone wants to try out.
Hey guys, like if you give me 2 minutes, I will try to explain in a hopefully better way. But I'm asking for 2 minutes because I will be in a place where I can actually talk. So go on.
Sure, Roger. It's fine. Actually, we are discussing some cases only. Then Puneet is asking for number 8.
For number
8.
8. For a single digit number, we could return 7 only. We could return
-1. Yeah.
Which is 77 or
no 7.
No. Single digits.
Okay, 7 or 9.
We'll return 7 for all the time because we need to return this number 1.
Okay, yeah, 7 is a got. 7 is also mirror image. So did we solve this particular problem? Sorry, I haven't touched with that. 9999. Like our answer should be 1001. That's one of the problem we need to handle that. Correct?
Yeah. The answer must be this.
I think Roger will explain more. The answer is 100.
10,001.
Yeah, 10,001. Correct.
It would be this, right? This is the wrong one.
Yeah, I think when you are doing mirror image 10, I think somehow we need to ignore.
But if we know if these are the only cases, then we can probably handle them. But not sure.
Okay, I'm on. Can you hear me? Hopefully
Yes.
Yes.
not
Yeah,
too much
Roger.
noise.
Yeah. Do you want to share your screen?
Sorry guys, I'm walking.
Oh,
So
okay.
yeah. So we will talk about couple of things. Like uh, you have a number of n digits. Do you agree that our palindrome could be of n plus 1 or n minus 1 digit? Is that
Yeah.
Yes.
right?
Yeah.
So let's get rid of the special cases. Whenever I'm moving from n digit to n plus 1 digit, I would like to go to the smallest n plus 1 digit.
Mm-hmm.
True? For the so that delta will be less. So,
True.
right? So what could be the if I have some 97 and I'm looking for the smallest three-digit number, which is a palindrome, it will be 101,
Yeah.
and that is that is static. Like without thinking, I can tell what is the smallest three-digit number, four-digit number, five-digit number. There,
It will
right?
be 99, I guess.
No, like three-digit smallest palindrome number is 101,
Yeah, yeah,
right?
yeah. Yeah, 3 digit would be 101.
And four-digit will be 1001. You will have
Yes.
one
Yeah.
one on the end and then just zeros, right?
Yeah.
Yes.
Okay. Now, if I am coming to n minus one case, like when I had a n digit number, and I am going to n minus one digit palindrome case, then I will like to choose the biggest number so that my delta will be different, least. Is that fair? Because
Sorry, can you explain this again?
yeah, so suppose you have any three-digit number,
Mm-hmm.
and my candidate is a number which is of two digits, I would always choose 99 because anything smaller than 99 will be far from that number because that number is three digits. And when you will try to subtract any value of two digits, it will be more than what I will get from subtracting just 99.
Okay. You are taking the upper cases means.
Yeah, I am just choosing those first those two cases. Either we go up or we go down, and then we will focus on the core crux where you guys were talking about.
Yeah.
So
Okay.
if so, these two cases are pretty clear, right?
Yes.
Yeah. N plus
Okay,
1 and n minus 1 is clear.
clear. So we have these two candidates. We will evaluate them, especially, right? Now, what about the case where we have n-digit number, and my solution is also going to be n-digit number? So
Yeah.
somebody already thought about mirroring the stuff, which
Yes.
makes yeah it
Yeah.
totally makes sense because palindrome, it's the nature of palindrome to get mirrored. So
Mm-hmm.
we could have thought about mirroring the right part. Right means the least significant bits towards left versus less significant bit towards right. But we chose to mirror left significant bit because that will make our
Smallest. Yeah.
delta smaller. So
Right.
that's a very nice thinking that way. Now I will explain take any number, like take 2, 3, 4, 5, 6 for example, because this is where we have to do something.
Okay.
So can somebody write 2, 3, 4, 5, 6? I can't see that much, but it's still I can see
Uh,
your writing.
can you write 2, 3, 4, 5, 6? Yes.
Yeah, yeah, yeah,
Yeah.
yeah.
Yes.
And as I guess Yes was explaining, like
Mhm.
when we are trying to mirror, we will mirror it to 2, 3, 4, 3, 2. That's right.
Yes.
Yeah.
Yes.
Okay. So that way your delta will be like 56 minus 32, right?
Yes.
Which is a very good solution. So it's a very valid candidate. Now, just think like if I am changing my number from 2, 3, 4, 5, 6, and I will say why I am changing, but just think for now, like 2, 3, 4, 5, 6, I want 2, 3, 4, 9, 9, for example.
499.
23499.
Now try to apply the exact same thing which Yes was trying to, like not Yes, like let's try the same thing which we just did, like
23432.
23432. Okay.
It will be
Now
23432. Yeah.
yeah. And so what happened now? If you see the delta is 99 minus 32, right?
Yes.
Yeah.
Okay. It's more than 50 for sure, right? More
Which is
than 50.
67, yeah.
Yeah.
Yeah, that's 67.
Now had we
50.
Sorry.
yeah, exact is not like it's fine.
No,
Good
it's
enough.
67.
67, it's 67.
67, yeah.
Okay. Now suppose if I would have changed instead of 234, I would say 23332. Like your new candidate, if it becomes 233. So no, same example. Your number is same, like 23499, but now you are saying
Okay.
that
23499 and it goes to
23332.
2332. Is that okay?
Yeah. What is your delta?
No, there are
It's more
two
than
things.
100, I think.
499 332.
It's quite a big number, right?
Yes.
Yeah.
And what about if I would just compare it with 23532?
That'll be smaller.
23532.
23532. We don't want exact subtraction, so don't worry. Like we'll just get something out of it.
It's 33, it's less than 67.
Exactly. So why that happened? Because you had a number at the 100 place. Some number is like at a 67 distance from it. So if you go to the other end, you will get closer to the number, because it's always 100 difference between 400 and 500 and 600, right?
Mm-hmm.
So that's the point that we decided, hey, let me compare this with 23532, because maybe I will get closer to the number rather than just comparing with 23432. And so the significance of going up here. Like 23532 is a good candidate because it is better than 23432. Is that clear? Or take your time. If it is not clear, we can spend more time.
Yeah, I got your approach because it's making like taking in other case, it's making us smaller rather than just going for
So
that.
yeah, one question, Roger. So 100 is key here because the thing which we are changing was 2-digit, right? The mirror image was 2-digit.
Exactly.
So 100 is the key.
1000, exactly.
Yeah, if it is 3-digit, then 1000 is our key.
Totally.
Got it. Yeah.
So
Yeah.
that's
Nice
the
explanation.
intuition.
Yeah.
So now, just to finish that, like choose a number, call it 99. Start with 99, and then whatever was our previous number, it doesn't matter. 456 maybe.
Okay.
Or yeah, maybe. Or maybe make it 432. Like, that should be okay. So again, if you go with the same approach, now when you will mirror it, like without changing the digit, it will be 99499 maybe.
Yeah.
Almost a difference of 67 here.
Yeah.
Cool.
Okay. And if you go up, so 99599.
432 299
5.
Yeah.
599.
Will it be even more far, right?
Yeah.
But if you go to 99399,
432 299 399.
yeah, so the delta will be very close, actually 33.
Yeah. 33.
All I am doing is, like on that number line, I am trying to go left or right to get as close as possible to the number. I mean, that's the core intuition part of the solution, right?
So, Roger, how do I decide whether I move down or up, or should I compare every time?
No. So what we are doing, like you don't know that what number could be. So you are
Yeah.
deciding all the possibilities your number could be in. So we had two special cases. When we go, like, when the number itself changes, then the solution will be 10001. If number goes down, then it will be 9999, something like that. And the middle case where, like, palindrome will be of the same length, that can be handled by this particular approach. Three cases for this middle case, basically. So you have total 5 cases. So what you will do, you will generate 5 candidates for any number, and you will just select whatever is best for you, and that's it, actually.
Yeah, Roger, one question.
Sure.
This approach that you are telling about, I think this is required for when we will have odd number of digits.
It will work for even also.
Do we need it for even?
No, what I'm trying to say that don't go case by case. I'm saying just you make 5 cases. Now inside this 5 case, everything is already covered. It will be easier to code if you directly generalize this thing.
Got it.
Yeah, got it.
Yeah, so you don't handle each case.
But I still have one doubt.
Sure.
I think we discussed 4 cases. What is the 5th one?
First one was 1001. Second was 99 case, right? When you want to go down.
Yeah. So n plus 1 and minus 1. Yeah, there are 2.
Yeah, and then third case was the base case, which yes was in the beginning mentioning that you just mirror the left part to the right part and you get the best solution.
Got it. So we are considering that also as a candidate.
Yeah, because it was solving a lot of cases already.
Solving the problem.
And these 2 extra cases when you flip the middle element, because now you are on a number line, you want to go closer into the towards the other end.
Yeah. One time increase, one time decrease.
Yeah, I will share the code, and I will say it's not my direct approach. I had solved it a year back, and it was in my saved code, so I will share it. So now you know the idea, so now it will totally make sense, I believe.
Could you please tell the 5th approach of 4 I have mentioned?
I think the 4th one is actually 2 cases. Flick middle element. One is you have to increase, one time you have to decrease.
Okay.
That's why we started with that 99 number to begin with, because I want to go to the other end of the line. That's why I chose, because when you will mirror anything which is ending with 99, you are very close to the next bigger digit, right?
Yeah.
So that's why that case works. Any question?
Puneet is saying he shared the code on chat.
Okay, great. If that is the same approach, it should be. Oh, my code is there on the. Okay, good. I will share this approach maybe by evening today.
Yeah, sure.
All right.
Okay, thank you so much.
Thanks, Roger.
Thank you.
Thanks for that was the case we haven't discussed about, and that's the that helps a lot. So anybody else, anything they want to discuss and end with any approach? If it is not,
I think we are just on time.
Yeah, we are on time. I think I need to stop recording now. And yeah, thank you.
Yeah, should I stop sharing the screen?
Yes.
Yeah.